In this presentation, we are going to solve our problem number 6 based on transfer function. So, let's get started. Part 1. Find the transfer function of the following circuit. The circuit is given to us. And part 2. What is the order of this circuit? So, we are given a circuit in which 3 inductors L1, L2 and L3 are connected in series and 2 capacitors C1 and C2 are connected in parallel. The input voltage VIT is given to the circuit and the output voltage is measured across the capacitors, which is VOUT. And we need to find out the transfer function and we need to calculate the order of this circuit. Can you guess the order of this circuit now? The order of any circuit is equal to the total number of effective energy storing elements. So the order of this circuit is 5, right? Because 3 inductors and 2 capacitors are connected. So 3 plus 2 is equal to 5. The order is 5, right? I want you all to pause this video and comment your answers for part number 2, that what is the order for this circuit. And then we will see that how many people have given the correct answer. So moving on to the solution, in this circuit we are given 3 inductors connected in series and 2 capacitors connected in parallel. And we know if the inductors are connected in series, then the equivalent inductance is the sum of all the inductances. And if capacitors are connected in parallel, then the equivalent capacitance is the sum of all the individual capacitances. That is, L equivalent will be equal to L1 plus L2 plus L3. That is the individual addition of all the 3 inductances. And since the capacitors are connected in parallel, then C equivalent is equal to C1 plus C2, which is the individual addition of these 2 capacitances. So if we convert this circuit to its equivalent circuit, then we will get this circuit in which L equivalent is equal to L1 plus L2 plus L3 and C equivalent is equal to C1 plus C2. So now, what is the order of this circuit? It is equal to 2 because only 2 effective energy storing elements are present in this circuit. In the given circuit, there were 3 inductors and 2 capacitors. So some people can say that the order for this circuit is 5, but it is not 5 because the order of any circuit is equal to the total number of effective energy storing elements. And in this circuit, these 3 inductors are effectively equal to 1 inductor whose equivalent inductance is the sum of all the individual inductances. And these 2 capacitors which are connected in parallel are effectively equal to 1 capacitor having an equivalent capacitance of C1 plus C2. So the order for this circuit is equal to 2. So now we are done calculating the order of this circuit. Let us now find out the transfer function. And we all know that the first step is to find out the Laplace equivalent circuit. So this is the Laplace equivalent circuit in which the input voltage is VIS, the output voltage which is measured across the equivalent capacitance is VOUT. The impedance of inductor is S multiplied L equivalent, where L equivalent is equal to L1 plus L2 plus L3. And the impedance of capacitor is 1 over S multiplied C equivalent, where C equivalent is equal to C1 plus C2. And we know that the inductor and capacitor are connected in series. And when the elements are connected in series, then the voltage gets divided. So we can find out the output voltage which is measured across this capacitor by using the voltage divider rule. And it is given as VOUT is equal to VIS, which is the total input voltage multiplied with the impedance of capacitor, which is 1 over SC equivalent, divided by the total impedance of the circuit, which is equal to SL equivalent plus 1 over SC equivalent. If we transpose VIS to the left hand side, then we will get the ratio of VOUT over VIS, which is equal to 1 over SC equivalent divided by SL equivalent plus 1 over SC equivalent. Now, if we multiply this factor SC equivalent with the numerator as well as with the denominator, then we will get the transfer function HS is equal to 1 over 1 plus S squared multiplied with L equivalent C equivalent. And this is the transfer function for this equivalent circuit. So in this way, we have calculated the transfer function for this circuit, and we have also determined the order of this circuit. And now we are done with this lecture. Try this homework question on your own, and when you get the answer, post them in the comment section. And if you have any doubt, you can post that too in the comment section. Thank you for watching this lecture. I'll end this lecture here. See you in the next one.